So in this video, I'm going to quickly go through some of the things about energy and the environment. I'm also going to quickly talk about how to solve for efficiency. So in the last hundreds of years, what has happened in our population, you can see this graph. In this graph, you can see that the population has steadily increased over the last kind of a little bit over 100 years. This obviously stops at 2000, so we have 20 years of increases as well that have happened for this year. And in that time period, as the population has increased, so has the increase for energy consumption. So basically, because the world has become more industrialized and the population has increased, and people have kind of started to occupy different areas of the world that are a little bit more cold, and vehicles and houses and all that fun stuff use oil and gas to be heated and ran, that energy consumption has increased. So that has affected the environment by increasing, because it's increasing the energy, and most of these things are creating some sort of pollution, like carbon dioxide, for example. The amount of pollution in the air has also increased exponentially in the last 100 years. So the reason that this increase has happened is because exponential growth in the population, and because basically the world has changed. So before, hundreds of years ago, like for example, farms would use just manpower, or like horses or donkeys or mules to basically farm the land. And now electricity and all of that stuff has changed how we do things. So when we're talking about efficiency, how energy efficient certain things are, we can use the formula for efficiency, which you guys probably have done before. So you do output energy over input, and then you multiply it by 100. Now, if you're not sure exactly in the question which one is the output and the input, you always just put the bigger number on the bottom. So however much energy is coming in is never going to be larger, or sorry, it's never going to be smaller than how much energy is going out. Because we create heat, heat is a wasteful energy. That means our output energy is always lower. And you should never ever end up with an answer that's above 100% for this. So if you do, that means that you probably have these backwards. Nothing is 100% efficient ever because of heat. So even like if you look at the efficiency of your car, the efficiency of your car is lower if your engine is not working as well. So newer cars are a little bit more efficient because they have usually less problems in the engine, less rubbing happening, all the fluids are filled properly, and creates less heat in the engine, which causes our output energy to be a little bit higher, versus if we're creating heat, all that energy is then lost to the environment and we can't get it back, and we don't use it for our actual usable energy that we're using. So if we're doing a calculation for this, it says calculate the energy efficiency of a water heater. It uses 200 joules of energy to increase the thermal energy of the water by 55 joules. So for this question, our efficiency, remember, is equal to output over input, and then multiply by 100 so that it's in a percentage. So our question would be 55 joules divided by 200 joules, and then multiply by 100%. And when you do this in your calculator, I ended up getting an answer of 27.5%. So that's basically how we do this. Not super, super difficult. Okay, so for the second question, I'm going to look at the automobile engine, which says that it's 20% efficient. So this time it's giving me my efficiency right off the bat. I'm not actually looking for it, so I'm going to have to do some rearranging of my formula. It also tells me that my output energy is the one that I'm looking for. So that's the one I'm going to solve for in my equation. And my input energy is 44.5 megajoules. So it doesn't tell me I need to be in a certain in a certain unit. So I'm just going to leave my answer in megajoules just to make this question a little bit easier. So starting off, I'm going to just look at my original formula, which is output over input multiplied by 100. Now the issue with this question is I need to solve for output, which means I need to rearrange some stuff. I need to put this onto this side and this onto this side as well. So to do that, I have to do opposite operations. So I'm just going to erase these lines. So opposite operations would be, I have to, for this one, it's being multiplied. So I have to divide by 100 on both sides. Okay, this side would cancel out the 100%. So I'm left with efficiency divided by 100% is equal to output over input. Okay, I'm going to now put the input, I'm going to try to put on this side. So right now it's being divided by, so I have to multiply by input on both sides. Again, it's going to cancel this out. So I'm left with my final equation. I'm just going to rewrite it in the opposite orientation. So my output is equal to my efficiency divided by 100%, and then I'm going to multiply that by my input. So when I do that, I'm going to put my numbers in now. So 20% divided by 100%, which is just basically taking it out of my percentage and putting it into decimal, and then multiplying that by 44.5. So when I put that into my calculator, I ended up getting 8.9 megajoules as my answer. So that is how you calculate efficiency. Unless it specifically says that you have to change it into joules, I think it's okay to leave it as megajoules. So don't have to worry about that energy, that conversion of units. So that's all I have to talk about today in my video. So hopefully that makes sense. We're going to be doing some practice questions in an assignment after I teach you one more concept tomorrow. So today is a pretty easy day. You can just kind of write these notes down with me and then kind of chillax for the rest of the day. So hope you have a good one. Talk to you guys later. Bye.